Hello, this is Bill from FLL Team 9462, the Blockinattis. This video will show you how to build a myblock that will drive your accessory motors, allow you to move them to positions consistently, and more importantly, will never hang up. From the red tab, select a briefcase. Set it to right numeric, select add variable, and type in a space time. Hold down the control key and the left mouse button to drag copy. Select right logic, and in the variable box, select add variable and type in A brakes. Drag copy the first briefcase and select the variable box, add variable, and type A degrees. Drag copy the third briefcase, and in the variable field, select add variable and type A power. Drag copy the A brakes briefcase, and in the variable field, select exit. From the yellow tab, drag a timer block and select reset and select timer 2. From the orange tab, select a loop and drag it out to fill the screen. For the exit condition, select logic. Expand the loop a little more to make room for several blocks. From the red tab, drag a briefcase and select read numeric, then select the variable name A time. From the yellow tab, select a timer block and select timer number 2. From the red block, select a compare block. Select operation greater than or equal to, then connect the A time to the B tab and the timer output to the A tab. From the red tab, drag a briefcase and select read logic and variable exit. From the red tab, select a logic block. Select the logic operation A or B. Connect the output of the compare block to the B tab of the logic block. Then connect the output of the read exit to the A tab of the logic block. Connect the output of the logic block to the loop exit control. From the yellow tab, drag a read motor block and start a new line of code and select the A motor. Create a second branch by connecting the loop to the A motor read block. Drag copy the read A time block and change the variable to A degrees. From the red tab, drag a compare block. Select the compare operation greater than. Connect the output of the read A degrees to the A tab and the read A motor to the B tab. From the orange tab, insert a switch and change it to tabbed view. Change the switch to type logic, then connect the output of the compare block to the input of the switch. Drag the switch out to the right of the loop block, then move the whole row down a little. From the red tab, drag a briefcase and select read numeric, then select variable A power. From the blue tab, select an unregulated motor. Select motor A and then connect the A power to the motor. Copy the blocks in the true side of the switch, then switch to the false side of the switch, or X side, and paste them in. From the red tab, select a math block and place it between the read block and the motor block. Select operation multiply, and in the B tab, type -1. Connect read A power to the A tab of the math block and the output of the math block to the motor control. Scroll down a little and make the loop big enough for a third line of code. Then select the second line of code inside the loop and copy. Paste the copy in the blank space, then connect this third line of code as a parallel branch by hooking it up to the loop. Delete all the blocks on the false side of the switch. Then switch to the positive side and delete those blocks also. From the red tab, drag a variable block and select Write Logic and Variable Exit. Shrink the switch block to make room for another block. The logic block inside the switch should read true, not false. We'll fix that later in the video. From the red tab, insert a math block and select Type Advanced. In the formula window, type absolute value, parentheses, A minus B, close parentheses. Reconnect the Read A degrees to the A tab of the Advanced Math block. Then reconnect the Read A motor position to the B tab of the Advanced Math block. Connect the output of the Advanced Math block to the A tab of the Compare block. Change the Compare logic to less than or equal to, and in the B tab type the number 5. Time to add some comments to our code. First we'll start with creating room up at the top for the first thread. This thread checks to see if the block has reached its time limit or if the exit variable is true. In either case, the A or B logic will cause the loop to exit. The second thread checks to see if the motor is where you want it to be. It then uses logic to move the motor in the correct direction to get it to where you want it to go. Scroll down to the third thread. This third thread checks the absolute value of the difference between the current motor position and the target position and compares that to a desired range. In this case, it's plus or minus 5 degrees. It then sets the exit condition to true if the motor has moved into the desired range. This is where we fix the exit condition to true. Scroll to the right to make room for 2 blocks on the right side of the loop. From the red tab, drag a briefcase and select Read Logic, then select Variable A Brakes. From the green block, drag a medium motor controller and connect the output of the Read A Brakes block to the control input on the motor block. Zoom out, then select everything but the play button, and then from the Tools drop-down, select myblock Builder. Select the medium motor icon. In the name block, type A_motor_control. Type a description like this block moves the motor to the desired position. It uses the same relative position throughout a mission. So once you set your motor position at the start to the 0 you want, wherever you tell it to move during a mission, it'll move to that position. Add 4 variables to the myblock by clicking the plus 4 times. Select the Parameter Setup tab and select the first variable. In the namespace, type A space power. Select the vertical slider. Set the minimum value to 0. Set the default value to 75. Select the Parameter Icon tab and then select the Power icon. Select the second variable. Select the Degrees icon. Select the Parameter Setup tab and in the name block type A degrees. Select Horizontal slider. Then set the minimum value to minus 9,999. Set the maximum value to 9,999. Leave the default value set to 0. Select the third variable. In the name block, type A brakes. Select data type logic and set the default value to true. Select the Parameter Icon tab, then select the red block. Next, select the fourth variable tab. Select the stopwatch icon. Select the Parameter Setup tab and in the name field type A time. Select the vertical slider. Then set minimum to 0. Then set the maximum to 20 and then finally select the Finish button. Connect time to a time, connect brakes to brakes, connect degrees to degrees, and finally connect power to power. Here's what your myblock should look like. The first thing you want to do on your robot is find out the range of travel of your accessory. In this case, we have a forklift, and the range of travel, as read by the motor readout on the software, from the bottom to the top is minus 709 degrees. The first thing you want to do for the start of a mission is, while you're in base, use the motor controller to move it to a known position, like all the way up. If you use a low power, it'll stall out when it gets to the top. Next thing you want to do is to set this condition to 0. So in this case, 0 means the forks are all the way up, and positive 709 means the forks are all the way down. Next, we'll insert a series of these motor control blocks to simulate moving the forks up and down during a mission. This first block is set to 200. Next, we move the forks to position 500. Then we'll insert a third block that moves it all the way down to 690. Next, we move the forks back up to 0. And then finally, we drag a block that moves it to position 200. Now let's watch this program in action. Notice how the forks move to the desired positions of each of the motor blocks. This is handy in missions. You can move the forks to where you need them to be at any point in the mission just by putting in the desired motor position number in the control block. Thanks for watching. Remember to like this video and to subscribe to our channel. Thanks.